Balancing equations. A chemical reaction cannot create or destroy atoms. It just can't. Nor can it change one type of atom into another. A chemical reaction just changes how the atoms are combined. It will change one set of particles into another. The number of each type of atom has to be the same before and after a chemical reaction. That's another way of stating the conservation of matter. The mass of each atom is also unaffected by a chemical reaction. Since the mass and the number of each type of atom is unchanged, the total mass of the atoms before and after a reaction is the same. If we start with 4.2 grams of substances, we end with 4.2 grams of substances. This is the conservation of mass. The particles present before the reaction takes place are called the reactants. The particles present afterwards are called the products. Between the reactants and products is an arrow pointing from the reactants to the products. Balancing a chemical equation is done to assure that conservation of matter is upheld. The number of each type of atom is not changed by the reaction. If that is violated, the reaction cannot take place. This equation shows two hydrogen atoms combining to form a hydrogen molecule. To determine if it's balanced, we first need to understand coefficients and subscripts. Normally, we don't show these if they're 1, but we will add them below for clarity. Also, we'll use color to clarify which is which. So the coefficients are the numbers in front of the atom, and the subscripts are these little guys right to the right. Coefficients show how many of each particle you have. So here's 2, and here's 1. Those are the coefficients. Subscripts show how many of each type of atom are in the particle. To see how many of each atom are on each side of the reaction, multiply the coefficient times the subscript for that atom in each particle, then add them up. In this case, on the left, there are 2 hydrogen atoms. 2 times 1, 2. On the right, there are 2 hydrogen atoms. 1 times 2, which is 2. The equation is balanced. Notice there are 2 particles on the left and only 1 on the right. We're not balancing particles, we are balancing the atoms. When we are balancing an equation, we can't change the particles we are given on either side of the reaction. That means we can't change the subscripts since those describe the particle itself. We need to change how many of each particle are on each side by changing the coefficients. So we have to change the 2 and the 1 if it doesn't work out. To count the atoms on each side, you need to know that subscripts tell you how many of each atom are in a particle. Coefficients tell you how many particles. Coefficients or subscripts are 1 if not indicated. See, we're not indicating any numbers there. That means it's 1. Multiplying the subscript and the coefficient tells you the number of each type of atom in that particle. If the same atom is in more than one particle, just add them. The first step in writing a chemical equation is usually to write an unbalanced equation, just the reactants and the products. At this stage, we're not concerned with whether it is balanced or not. This equation says that a hydrogen particle and an oxygen particle combine to form a water particle. In the atmosphere, both these gases only occur as diatomic molecules, so that's our starting point. That's why you have those 2's there. Now let's check to see if this is a balanced equation.